Hi everyone, in today's lesson we're going to talk about how to solve equations by completing the square. Before we can actually get into solving by completing the square, I'd like to review a few things first. First, I'd like to review what is a perfect square. A perfect square is a number or an expression that is the result of two of the same things multiplied together. So for example, 25 is a perfect square because it's the result of 5 times 5. How about x squared? X squared is a perfect square because it's the result of x times x. Okay? How about 4x to the 6th? That's a perfect square as well because that one's the result of 2x to the 3rd and 2x to the 3rd. So these are all perfect squares that we've learned before. Now we can also have perfect square trinomials. So a perfect square trinomial is a trinomial that is the result of two of the same binomials multiplied together. So if I took these two binomials that are the same and double distribute them, you would get x squared plus 8x plus 16. So that makes this trinomial a perfect square. Now let's look at these two binomials. We're multiplying two of the same binomials together, and if you double distributed everything, you would get x squared minus 6x plus 9. Now this trinomial would also be a perfect square trinomial. So what do all perfect square trinomials have in common? You may not be able to see it just by looking at just two examples, so I'm just going to tell you what it is. A perfect square trinomial is any trinomial whose c value is half of the b value squared. Now I know that's a lot of jargon, and what does that really mean? And we could put it into words. It's really you're going to take half of the b value and square it. And we want to see if that gives you the c value. Now what do I mean by a, b, and c? We've gone over this a few times, but remember we have a trinomial that's ax squared plus bx plus c. So let's just prove to ourselves that these two trinomials fall under this same pattern, that their c value is half of b, or b divided by 2, squared. So let's look. My c value here is 16. Is that half of 8 squared? Well, let's do the math. 8 divided by 2, that's half of it, squared. Well, half of 8 is 4, and then 4 squared is 16. Okay, that one works. Let's look at the second example. Take half of the b value. The b value is negative 6. We're going to have it. And square it. So negative 3 squared, is that equal to 9? Yes. So in both of these cases, my c value was half of the b squared. Okay. Now let's look at 3 more examples and determine if they're actually perfect square trinomials or not. And if they are, let's factor them. So let's look at example number 1. To see if it is or not, we're going to look at the c value and see if it's half of b squared. So we're going to take negative 2 divided by 2, and I'm going to square it. So negative 2 divided by negative 2 is negative 1. Negative 1 squared is 1. Okay, so that works. Let's look at example 2. Half of b, so we're going to take 10 divided by 2 and square it. 10 divided by 2 is 5. 5 squared is 25. So that works nicely. Okay, now let's look at this last one. We're going to take half of the b, so negative 12 divided by 2, and square it. So negative 6 squared is 36. So that one works as well. Now let's factor these. So if you notice, we can just use the AM method for these because the a is equal to 1. So if I look at this quickly, this will just be x minus 1 times x minus 1. Number 2 will be x plus 5 times x plus 5. And number 3 will be x minus 6 times x minus 6. Now, do you notice anything in particular to how we could just write these? Can't we write them as x minus 1 squared? Can't I write this as x plus 5 squared? And this as x plus 6 squared? because anything times itself is that same thing squared. So this is just a quick way of realizing that you really don't have to do AM. What you really could compare is that when we take half of it, half of b, we get -1. So look at this, -1. When I took half of my b, which is 10, I got 5 and squared it. So that 5 went in here. Half of b is 6, that goes there. So the rule is it's going to be half of the b value will help us factor. So all of these guys in here are half of the b value. So let's see if we can put this all into perspective. Determine what the c value would have to be to make this a perfect square trinomial, and then rewrite it as a binomial squared. So first one, in order to find the c, we have to take half of b, so -4 divided by 2 squared. Now -4 divided by 2 is -2, and -2 squared is 4. So that's my c. Now why did I write all of these steps out? Because remember, when we took half of b, we got this step. This is the step of my factoring. So it's going to be x minus 2 squared. Okay, so for number 2, we're going to take half of b, which is 6 divided by 2, square it. So we'll get 3 squared, which is 9. So that's my c value. Now remember, half of the b value, which is the 3, tells us how to factor it. So it'll be x plus 3 squared. Now example number 3, take half of b and square it. So I get 5 squared, which equals 25. So that I'll put there. And this half part is what tells me how to factor. So those are my pieces. So if you could do this page, you definitely can factor by completing the square. So let's go to the next page. Okay, so we're going to solve each of these expressions or equations by completing the square. So the first step is what we're going to take this constant and move it to the right hand side. So we have x squared minus 8x equals -24. Basically all I did was subtract 24 on both sides. That's how I got the -24. Now we have to make a perfect square trinomial out of these two. So we need to basically find a c value such that when I add it to this side of the equation, it'll be a perfect square. So remember, from the previous page, we take half of b and square it. Half of -8 is -4. -4 squared is 16. So this is the 16 that I'm going to add to make this a perfect square trinomial. But in order to keep the equation balanced, I have to add that 16 to this side as well. So now that it's balanced, we could technically just add these right hand numbers together, and we get -8. And we can factor this trinomial, and from the previous page, we remember that it's just going to be this middle term. So x minus 4 squared, it's basically half of 8. And now we can solve. So in order to get rid of this squared over here, we're going to have to take the square root. So we take the square root of both sides, that goes away, and we're left with x minus 4 equals, don't forget the plus or minus, and I'm going to take out the I while I'm here, plus or minus I radical 8. Then we could add the 4 to both sides to get x by itself. So x equals 4 plus or minus I rad 8. Now we probably should break up this radical 8 into radical 4, radical 2. So 2 rad 2. So my final answer, don't forget about this I, is 4 plus or minus 2I radical 2. Okay, let's try a different example. Let's try an example where a is greater than 1. So the a value is just what I mean here is this 2. So is it set up correctly? Is it set equal to the constant? The answer is yes. So we're pretty much good to go there. So now we need to figure out what value makes this thing a perfect square trinomial. The only problem is that my a value is not 1. So we actually have to take out that GCF of just the 2. We don't worry about the x's, but we're going to take a GCF out of 2, and we're left with x squared plus 8x equals 8. So now this is the thing that you want to make the perfect square trinomial for. So half of b, the 8 is the b, this 8 here. So half of 8 squared, so 16 again. So we have 2x squared plus 8x, and we have to add that 16 to this side of the equation. If I'm going to add 16 to that side, I really should be adding 16 to this side. However, I'm not really adding 16 because when you technically distribute this 2, it's really like you're adding 32. So it's kind of like the rainbow thing. We'll say we'll move this to this and this to this, and that's how we get 32. So it would be 2 times 16 gives me this 32. Okay? That's the only difference between those first two examples. And then we do everything just the same. So we're going to add these two together, and we get 40. We factor this trinomial to x plus 4 squared this time, because remember we're going to use this value. And to get this x squared by itself, we first have to divide the 2 on the outside. We get x plus 4 squared equals 20. Take the square root of both sides, and you should be getting x plus 4 equals plus or minus again, square root of 20. Subtract 4, you should get x equals negative 4 plus or minus radical 20. And again, break up the radical 20 into 4 and 5. So 2 rad 5. So x equals negative 4 plus or minus 2 rad 5. Final answer. Okay, so just to recap, the only difference between this problem down here and this problem up here was the coefficient. You can't complete the square unless the leading coefficient is 1. So we had to take it out. And when we added 16 on this, you just have to multiply it by the GCF, so we would add 32 instead. Okay, we're going to leave these questions blank for today. We will come back to them another day.